All right, let's just jump right in with one of the biggest questions you can possibly ask. What if there was a single, unified idea that could explain the entire story of our universe, from its very first spark to its ultimate, final end? Today, we're going to explore a really fascinating framework that tries to do exactly that. You know, when you think about the biggest puzzles in physics, you have to wonder, are they all just completely separate problems? Or could they be different symptoms of the same underlying reality? That's really the central question we're digging into here.
Yeah, these are the big ones, right? The heavy hitters of modern cosmology. We've got names for them, dark matter, dark energy, but let's be honest, we don't really know what they are. They're these giant cosmic question marks that scientists are working so hard to figure out.
So the way science usually works is you tackle each of these mysteries one at a time. You have a search for the dark matter particle, a separate theory for dark energy, another one for cosmic inflation. And that approach has gotten us far, but it feels a little disconnected, doesn't it?
But what if that's the wrong way to look at it? What if we've been trying to solve a bunch of separate puzzles when really it's all one big, continuous story? A story that isn't told with particles or forces, but with information itself.
Okay, so let's put on this new pair of glasses, this new lens. We're going to dive into a theory called Unified Informational Cosmology, and it's built on a pretty radical idea, that we can weave all of these cosmic loose threads together into a single, coherent narrative.
So what is Unified Informational Cosmology, or UIC for short? Well, at its heart, it's this idea that everything, dark matter, the universe expanding, they aren't separate things. They're all just different features of a single, giant, evolving informational system. It's a way of reinterpreting the data we already have through a whole new framework.
Now this is a really important point. This isn't about throwing out our current physics. It's not replacing Einstein or anything like that. Instead, it's more like a mathematical overlay, a new language to describe what our telescopes are already telling us. Think of it like putting on a new filter to see the same sky in a totally different way.
And the credit for this framework goes to Kevin L. Brown, who's an independent researcher, inventor, and author. The goal here isn't to change the physics, but to see if this idea of an informational structure can give us a coherent and unified story for all these cosmic mysteries.
So, how does it all work? Well, the central idea is something called the triune field, and just so you know, that's pronounced triune, with a long I sound, like in time. It says that the universe's state at any given moment is a combination of three things: its total information, its energy, and its geometric structure. And these three elements are always interacting, always evolving together through cosmic history.
Okay, this is where it gets really cool. Let's take this informational lens and see if we can use it to reframe those huge cosmic mysteries we mentioned earlier, dark matter and dark energy.
So, dark matter. The standard view, right, is that it's some kind of weird, invisible particle we haven't found yet. But what if? What if it's not a thing at all? The UIC interpretation suggests that what we call dark matter is actually a kind of informational curvature, like a dense spot in the universe's underlying data that creates the gravitational effects we see.
All right, now let's talk dark energy. We usually think of it as this bizarre anti-gravity force pushing everything apart. UIC flips that script. It says the universe isn't being pushed. It's relaxing. It's naturally settling into its most stable, most simple state. Imagine a really complex system that's just run out of new things to do, so it settles into its most predictable, lowest energy state. That's dark energy.
And what's so powerful about this approach is that it's not just about solving individual puzzles. It's about telling the entire story of the cosmos from the absolute beginning to the very end as one single continuous process.
So check out this timeline. It gives you the whole story in one go. It all starts in this state of super minimal information, the quantum vacuum. Then it just explodes in complexity with inflation and the birth of stars and galaxies. And finally, as dark energy takes over, the whole system starts to simplify again, heading toward that final, stable state of informational quiet. It's a complete story arc.
Now, I know what you might be thinking. This sounds really neat, really elegant, but is it actually science? I mean, a core principle of any scientific idea is that it has to be testable. You have to be able to prove it wrong.
That very concept is called falsifiability. If you can't even imagine an observation that would disprove your idea, then it's not really a scientific theory. And proponents of UIC make it very clear that this whole framework is built on that very principle.
So, what could prove this whole framework wrong? Well, this slide lays out some really clear tripwires.
For example, if we suddenly saw the universe start to collapse back in on itself, well, UIC would be falsified. Done. Or if we prove the universe isn't fundamentally flat, or if the cosmic acceleration just stopped or went into reverse, any of those would do it.
So when you boil it all down, here's the key takeaway. Unified Informational Cosmology gives us a single flowing story for the entire history and future of our universe. It doesn't add any new physics, but it does offer a powerful new language, the language of information, to connect the dots we can already see.
And that leaves us with this one huge, mind-bending question to chew on. We're so used to thinking about the universe in terms of stuff, matter, energy. But what if that's like looking at a video game and only focusing on the graphics on the screen, instead of the code that's running it all? This framework suggests we've been studying the graphics, when maybe, just maybe, the real secrets lie in the underlying code. Could it be that the most fundamental building block of reality is in fact information itself?